this video, we'll be talking about slope as a rate of change. And we'll start by looking at the question, who runs the fastest? If I look at a graph, a distance time graph, that compares two people, maybe running a distance or walking a distance, am I able to determine which of those two people is running or walking the fastest? And the answer is yes, and it's an easy comparison. If I look at the green line and the red line, I should be able to notice, and you should be able to notice, that the red line is steeper than the green line. And when we notice that, when we see a steeper line, we can conclude that the steeper line is faster. So in this particular graph, the red line represents the person who is running or walking the fastest. I can make this exercise of determining who runs the fastest a little bit trickier by not placing both graphs, by not placing both lines on the same graph. Now we have a little bit more of a challenge in determining which line is steepest. We do know that speed is equal to distance divided by time. So on my two graphs, for the blue line and the purple line, I know for this graph, in 10 minutes, I've traveled 3 meters. So my speed is 3 over 10, or 0.3 meters per minute. In my purple graph, in 6 minutes, I've gone 3 meters. So my speed is 0.5 meters per minute. So here my purple line is the fastest. And I did that by calculating the speed by recognizing how long each line has been traveling for and how far each line has traveled. What we're really doing with these types of calculations is determining the slope of a line. The slope of a line is a measure of the overall steepness of a line. One way that we can represent slope in an equation is by saying that slope is equal to the rise of a line divided by the run of a line. Let me explain that with a picture. So here's another graph, and if I want to calculate the slope of this line using the equation rise divided by run, I look at two things. I look horizontally and vertically at how far up the graph has risen, so how much it's increased, and how far over the graph has moved. So counting up, I see that the graph has risen 6 units. Counting over, I see that the graph has moved over 4 units. So my slope for this particular graph would be 6 divided by 4, or a slope of 1.5. Let's do another one. Again, I look at the rise of this graph and the run of this graph. Here I see the rise is 2. It's gone up 2 units. And the run has gone over 4 units. So my slope, my rise divided by my run, would be 2 divided by 4, or a slope of 1/2. And finally, We don't always need to work with lines that increase as you look from left to right. Sometimes we'll have lines that decrease from left to right. But again, we can calculate the slope the same way. We can look at the rise and the run of the line. So here I see that the run is equal to 4, and my rise is equal to 7, but we need to remember that since this line is decreasing from left to right, since it's going down, our rise is actually -7. We use the negative to show that the line is going down. So my slope would be -7 over 4, rise over run. So just to summarize, we've looked at the equation for slope, and we've said that slope is equal to the rise of a line divided by the run of a line. And we looked at situations where we have a positive slope. Lines with positive slope look like they go up as we read the graph from left to right. And lines that have negative slope look like they go down from left to right.